Da, 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 da.
Oh, God.
Hey everyone, it's Wes with Robolink, and this is Kristen here. I've taken over the webinar.
No, you have not.
I'm just an invited guest.
Yes.
I'm not even invited to my own home every time. Anyway, so we are here to talk about the new CoDrone Python and Arduino libraries. We've kind of been teasing about them on the forum, and I wanted to give you all a sneak peek at what we're working on, what we're cooking up in the lab. So we've been checking the forum pretty actively over the last week. A lot of you have been posting pretty actively, which is really nice. So a lot of folks have been asking about sensors. A lot of folks, even before the forum, have been asking about, like, how do we tell the drone to go to a certain height? How do we turn at a certain angle? And how do we measure how high it is from the ground? So we've taken all of that feedback and
we've had a lot of people like asking us at events and at our center as well. So it's not just people in the forum; it's everywhere.
Yeah. So we're all listening to you, and we're taking that feedback into account. So I wanted to give you all a sneak peek at what the new library is going to look like. This might get a little bit technical, so strap in your seat belts, because it's going to get crazy and technical. So we've got, I'm going to show you all a quick overview of what I'm going to cover. Whoa, hold on a second.
No, it's fine.
Here we go. Yeah. So you can break down the new library into a couple different categories, and I've written out what they are here. And then I'm going to walk through just a few examples of what that code's going to look like. So we've got flight sequences, flight commands for starting and stopping, flight commands for movement, flight variables, sensors, states, LEDs, and audio. And so I'm going to explain what each of those are. Flight sequences is basically going to be examples of just telling the drone, I want you to fly in a spiral, or I want you to fly in a circle. Really simple stuff for beginners that can just, get you started, and off the bat you can see, oh, that's a square, oh, that's a circle, and it's just kind of simple to get you excited. Those are flight sequences. Flight commands for starting and stopping right here. That's just obviously your takeoffs, your lands, your emergency stops, the really simple ones right there, just to get you moving. And then flight commands for movement are things like pitching forward, throttling up, yawing left, yawing right, roll left, roll right, that kind of thing. And then flight variables is when you want to get more specific. So difference between commands and variables, what we've decided on is commands are going to be a little bit more literal, like move forward, move back. With variables, you're actually setting the variables of the flight. So things like throttle, pitch, yaw, roll. You're actually setting those variables, and that's similar to the way Snap works, and it's similar to how the Arduino commands work right now. So there's going to be a difference between these two in that if you want fuller command, you'll be using the variables. If you want just literal commands like fly or move up, move down, that kind of thing, then you can use these. Sensors, this is a big one. A lot of you have been asking, can I get sensor data? I think for math teachers, science teachers, just engineering teachers, you all are going to be pretty excited about this one, because we actually have finally figured out a good way to provide sensor data. It's probably going to come out in different phases, but essentially you're going to be able to access a good amount of the sensor data, even going to be able to print things out pretty quickly. Depending on what the drone is doing, it might be faster or slower, because you've got communication back and forth on the drone. So the more things you've got going, a little bit slower it might be. But that being said, you'll be able to do infrared height to check how high the drone is flying. You'll be able to access the gyro sensor data. You'll able to access the barometer data, which reads the temperature on the board and also reads air pressure. So we're trying to treat this whole category like a like you're flying, not just flying a drone, you're also flying a sensor, because drones have lots of sensors on them, and that helps them fly more stably. States are going to be things like, is the drone upside down? Is the drone flying? Is it not flying? Is it low on battery?
Ooh,
yeah, so you'll be able to check what the battery is, and then have it do something when the battery is low. LEDs, you all should be pretty familiar with this if you've been using the CoDrone. It's just the eyes, the arms. You can change the colors. It'll be a lot clearer how to change the modes, and we'll go through that really quickly. And then you'll also be able to change, like, is it pulsing? Is it blinking? Is it always just on? What color is it? That kind of thing. Audio, this part's new. And the drone itself doesn't have any audio, any way to produce sound. So what we've decided to do is we're going to use the computer's speakers to play sound. And this part we haven't quite finished yet, but the idea would be that you'll be able to use audio cues to trigger certain things, or when certain things are triggered. So, when it takes off, you might want to play like a rocket sound or something on your computer. So you'll be able to tie sounds to different actions that you create. This one is the most in development right now. So we have the least information about this one, but that's the idea of what we're working on. So I'm going to go over to the actual documentation that we're working on, and this is all going to be online eventually. But let's go through flight sequences first. So we've got down here, actually let me use this thing. Flight sequences. So basically you would be doing something like this. Actually, let me update that one really quickly. This one's, we're highlighting the ones, we're highlighting the ones that we're still not sure on. So let me just make sure that that is clear. So you would basically say something like fly sequence. I'm going to write the example code right here. Fly sequence, and then you've got your parameters, and then you would do something like this. Something like this. Zigzag. Or you might do something like spiral, or you might do something like square, and that's as simple as it is. You're just calling the zigzag or spiral or square sequence in the fly sequence function, and then it's going to fly in a spiral or a zigzag or a square. So far we've proposed doing square, spiral, triangle, hop, sway, and zigzag, and we might come up with a few more, and we might have to change these up. We're still testing those out to see how reliable they are. That one's pretty straightforward. They're just flight sequences. And then there's turtle turn, which the drone already does. It's anytime it's upside down, it's going to try to flip itself right side up. So those are your flight sequences, and then you've got flight commands for starting and stopping. That's going to be over here. Hold on a second. Here we go. Pretty straightforward, just those three. Takeoff, land, hover, emergency stop. Actually, that was 4. I can count, I swear. Hover, so there's takeoff, land, hover, and emergency stop. So now, rather than having to say like throttle 0 and everything else, set it to 0 and then do a delay for 5 seconds to hover for 5 seconds, you can just say right here, an example would be just hover 5, or sorry, it's going to be 5,000. So it's going to be in milliseconds.
Yeah, it's in milliseconds.
I'm not sure if we decided on. I think we decided we're going to go with milliseconds. Yeah. So basically, it would be hover and then just however many seconds or milliseconds. I think we might not have a consistent one yet, because Arduino and Python, they use different time measurements. One uses seconds as a standard and milliseconds as the other standard. So we're going to make that uniform between Python and Arduino. So you can just say hover for 5 seconds, and it's going to hover for 5 seconds, as you would expect. But it's much easier to read, which is going to be easier for students to learn, because you don't want to spend so much time teaching students about the very specifics of drones if they're just learning about programming to start off with. Our goal here is using the drone as a means to learn programming, right? So that one's should be pretty straightforward. And then we've got flight commands and movement. This one's exciting because it makes things a lot easier to read. So check this out. So there's going to be a move command that basically takes a bunch of parameters. It's going to be duration, roll, pitch, yaw, and throttle. And we did some searching around just to make sure this order made sense. And essentially, you've got what we found was this was the most common order for roll, pitch, yaw, throttle. And so basically, this is going to be the more complex function that says that you can use the drone to fly in like a diagonal direction upward. So if you're doing like just throttle or just pitch or just yaw, you're only doing Z, Y, or X at once. So with this function, you'll be able to do multiple axes. There we go. You'll be able to do multiple axes at once with a duration. Go is going to be similar to your send command in Snap, where after you've set things, I'm sorry. Go is going to be the simpler function, where you're actually just saying really simple commands like go forward, go up for 5 seconds. So there's going to be a 1 parameter version and then the 2 parameter version. This one's just going to say go forward, and then we're going to default it to 0.5 seconds if you don't give it a duration. So then you can just say, to start off, you can just say go forward, go forward, go forward, go forward. So if you call it 3 times, it'll go forward for 1.5 seconds. If you say go forward, comma 5, then it'll go forward for 5 seconds. And Python and Arduino are going to be a little different in that you've got, it's going to be go and then just capital left. Python is going to be go direction dot capital left, just to be syntactically correct with each of the languages. And then you've got turn degree. This one's also pretty straightforward. Similarly, it's just the direction, duration, and then power. You've got 3 versions, one with 1 parameter, one with 2, and one with 3. And then you're going to be able to say things like turn left. And again, it's going to be 0.5 seconds if you don't specify length or duration. And it's going to be at 50% power if you don't specify power. So here's an example of what that will look like. And then here's a really exciting one, turn by degree. So we've been testing this actually today. You're going to be able to do triangles and squares with relatively accurate degrees, because the drone, just the nature of drones, you can't get the exact degree, but it's pretty close. We've been trying out triangles today, and it's been starting off turn 30, go to one corner, do a 120, turn to, and then fly to the other corner, do another 120, and then you end up back around where you started. That one's going to be turn direction, angle, so 2 parameters. These are all crossed out because we either found them too difficult or we're going to work on it later. Rotate 180, that one's actually a built-in function. So you can already do that in Snap. And then go to height. This one is, we've been working on it this week. you're going to be able to tell the drone, I want you to go to, 5,000 millimeters. Oh, sorry, 5,000 is too high. So the IR height sensor actually only is accurate up to about 2,000. I think to be safe, I would say accurate up to 1,500. But up to there, which is about the height of a little bit shorter than like an average adult. Basically, that height will below that height will be relatively accurate. So you'll be able to say, go to 200 millimeters, go to 500 millimeters, go to 1,000 millimeters, and then the drone will slowly rise to that height, and then try to hold that position. And then here, sensors, get height, all pretty straightforward. You're just getting the height of the drone at its current position, get the pressure, get the drone temperature, and we wanted to make sure that it's clear that you're not getting the temperature of the air around it, you're getting the drone's temperature, the board itself. Angular speed, this is going to give you this kind of information right here, the roll, pitch, and yaw gyro data. Get gyro angles, this one's actually going to give you the angles of all those, all that sensor data. And then you've got your accelerometer data here, optical flow positioning here, and then you've got the state of the drone. And there are a couple different states that the drone can be in. There's ready, there's takeoff, flight, flip, stop, all these right here. And then get battery percentage. So you can actually read the battery percentage, read the voltage, get the trim that it's been set to, because you'll be able to adjust the trim. And then all this red stuff is still in development. State checkers is the drone upside down? Is it flying? These are all Booleans. Is it landed? And then on battery, is the drone low on battery? So all these are being edited. And then LEDs here are, now you're going to be able to say set the ARM RGB, and then in classes you'll be able to teach what RGB means, actually setting the R value from 0 to 255, set them all to 0 to make it black, or set them all to 255 to make them white, that kind of thing, which is a pretty universal system for web design or screen color output. You've got your set iRGB as well, and then you've got the set mode. So you're going to be able to do things like hold the color or mix the color. That means it's just going to change to a bunch of different colors. Flicker is just going to turn on and off. Flicker double is going to flash, and then dimming is kind of the pulsing pattern. I believe that was it. Oh yeah, audio. So this one is, again, I said we're still working on this, and so it's still kind of in flux right now. But the idea is you'd be able to actually say play sound, and then say like you decide that you want to put a horse sound into the file, so that your computer neighs every time the drone takes off, or neighs every time the drone does like a 360 or something. So you'll be able to do silly things like that, or fly the drone to the next room and say like, "Hi, Mom," things like that. Oh
yeah, teachers, parents, we apologize in advance, but kids, we hope you have so much fun with it.
Yeah. Again, the sound is going to come from your computer, so I think your mom or your teacher is going to have to be close enough to hear it from your computer. Yeah. But don't get too crazy, students. And then set volume, of course. And then this one's highlighted green because we're still gonna need to do some research on this one to see if we can do like just recognition of a phrase or something, so that you can just type in something. But I believe that's it. Yeah. So that gives you a sense of what we are working on. And again, all of this is in development still, so things may change. But we're aiming for a mid-March release of the first phase. So the flight movements and flight sequences, all the flight-related things, we're prioritizing those because it's a drone. So we want to make sure those are pretty solid. So we're aiming for that to be ready in mid-March. And hopefully you guys are excited about it. And it becomes more useful and easy to read for both the teachers and the students. Yeah. Anything else?
No.
Cool. All right. We will see you next week then. And leave any questions on the video on Facebook, or you can ask us on the forum at forum.robolink.com. Alrighty. Bye.